In lesson 5.3, we're going to learn how to identify outliers in a data set and also talk about resistant measures. We'll cover some calculator shortcuts in this lesson as well. So what is an outlier? An outlier is any data value or values that fall outside the pattern of the rest of your data. Now, there's some reasons why we might want to recognize outliers. First of all, they can indicate that a mistake was made in recording data. And if that's the case, you can either fix the mistake if you're able to do that, or you might want to throw out that data point. Number two, they can indicate a phenomenon that should be recognized. In sports, for instance, we might have an athlete that is an outlier compared to other athletes that play the same sport they do. And if that's the case, then we might want to recognize them as being a standout in their field. Number three, outliers can also have great influence over summary statistics, such as the mean and the range, and we'll see that in this lesson. So in example number one, we have salaries, including bonuses, for the top 10 highest paid athletes in the NFL in 2017. And so the first thing I did there is I made a dot plot of all those salaries. And you can just go ahead and pause the video and go ahead and make your own dot plot. But you'll notice that most of the athletes have salaries ranging from about 14 to 17 or $19 million per year. And then we have one point way at the end, which is Kirk Cousins, who made 23.9 million. So based on the dot plot, it looks like 23.9 might be an outlier because it doesn't seem to fit the pattern of the rest of the data. But we want to learn a mathematical rule for determining when a point is an outlier, and we'll see that in just a moment. Now in B and C, they're asking us to calculate some summary statistics, and this is where we're going to use the calculator shortcut. So go ahead and grab your graphing calculator, and what you're going to do is you're going to use the stat button. So we'll hit the stat button, and then the very first option that's highlighted when you do that is edit. And so you're going to hit enter and choose edit, and that's going to take you into the lists in your calculator. Now, it really doesn't matter what list you put your data into, but by default, it's probably going to go to list number one. And if you already have data stored in that list, you can go ahead and move your cursor up to the top right here where you have list one and hit the clear button, and that will clear out any data that's stored there. Then just go ahead carefully and type in the 10 data values from your notes. Now you're going to hit the stat button again. And when you do that this time, instead of choosing edit, you're going to choose calc. So just use your arrow to scroll over. And then the very first option that's already highlighted for you is one variable stats. And that's what we want to do because we're working with one variable, which is salaries, and we want to calculate some summary statistics. So when you choose option number one, you may or may not see a screen that looks like this, depending on what version of the calculator you have. Newer ones will ask you to put in the list that your data is stored in, and then you can also choose a frequency list if you want. And we're not going to use that function in this lesson, so you can leave that blank. If you have an older calculator, it might just show you one variable stats on a blank screen, and then you can just go ahead and hit enter, and it will do the one variable stats for you. So either way, we'll go down and we'll hit calculate, and then the next thing you'll see will be a screen that looks like this. And notice the very first summary statistic that they're giving you, X bar, that's the symbol that we use for mean. There are a bunch of other numbers here, some other statistics that we're not going to use. And then the bottom one where it says n equals 10 is telling you how many data points you have in your list. This arrow that's here indicates that there's more to see. So we can scroll down. And when we do that, we'll see some other summary statistics, including the median. And they're telling us the min and the max, which are the smallest and the biggest values in our data set, which is handy if your data isn't sorted. And then we also see the median there. All right, so we know now the mean is 16.91 million and the median is 16.45 million. The range we can get by subtracting the max minus the min, and we also can do the IQR by subtracting Q3 minus Q1. And at this point now, we want to learn the rule for determining whether data values are outliers, rather than relying on an eye test like we did for Kirk Cousins. And here are the steps. And we've already done a couple of these steps. So step number one is to find Q3 and Q1. And essentially what that does is it kind of marks out for you the middle 50% of your data. So just pretend like that represents the middle 50%. And then you might also have some more data that is above that middle 50% and some data that is below. Now, step number two is to calculate the IQR. The IQR is giving you basically the width of this middle 50%, so the distance between those values. So remember, this would be Q1 because that's the lower boundary of the middle 50%, and this would be Q3 up here, which is the upper boundary of that middle 50. Now we're going to multiply that IQR by 1.5, and that's just going to give us kind of like a safety net. And what we're going to do then is we're going to take that IQR times 1.5, and we're going to go down from Q1 by that amount, and that will set kind of like a fence. And anything inside that fence is good. Anything outside the fence is an outlier. We also want to go up from Q3 by that amount and set another fence. So anything outside those fences on either end will be an outlier. And sometimes you'll have outliers on both sides. Sometimes you won't have any outliers. Sometimes you'll have outliers on one side but not the other. It just depends on the way your data is arranged. All right, so let's actually go through those steps now with the NFL salary data. So we already found that Q1 was 15.5 and Q3 was 16.7. We also know that the IQR is 1.2, which we got by subtracting those two values from the quartiles. Now, again, let's go back up and look at our data. So 15.5 up to 16.7 is giving us the middle 50% of our data right there. And we have to take that IQR of 1.2 and we want to multiply that by 1.5. So that's step number 3. So 1.5 times 1.2 gives us 1.8. Now what we're going to do is we want to take 1.8 and we want to subtract it from Q1. So in other words, we want to go down from here by 1.8. Well, 15.5 minus 1.8 is 13.7. Now we want to repeat that on the other side. So from here, we want to go up by 1.8. And so that gives us 18.5. So then we're going to set some fences, okay? So those fences that I put in there, and let me clear out the markings that I made, show us how far we can go out from our quartiles and have our data points not be outliers. So this one right here represents 13.7. I put it below the 14. This one is at 18.5. And so anything outside of those fences are outliers. Notice in this case, we actually have 2 outliers. Even though we didn't initially think 19 was an outlier, it actually is when we use this rule to check. All right, we're going to go through that rule one more time. And in letter A, we're looking at NASCAR victories. And they're telling us that Richard Petty is an outlier, which we might have guessed by looking at this data, but we're going to go through all the steps mathematically to verify that. So step number 1, we want to find our quartiles. And I would just do this by putting these data into your list in your calculator. So Q1 is 54.5 and Q3 is 88.5. Step number 2, we want to find the IQR. So we subtract those two values to get an IQR of 34. Now our next step then is to multiply the IQR by 1.5. So 1.5 times 34 gives us 51. Now 51 is the distance that we can go out from each of our quartiles and have something not be an outlier. So we want to go down by 51 from Q3, and I'll show you this in just a second. And I want to go up by 51 from Q3. I'm sorry, I think I said Q3, but this is Q1. So go down by 51 from Q1, go up from Q3 by 51. So I'll show you those steps. So 54.5 minus 51 means that we can go all the way down to 3.5. And then 88.5 plus 51 means we can go up to 139.5. Well, we don't have any values in our data set that are less than 3.5, so we have no outliers on the low end of this data set. However, on the high end, 200 is greater than 139.5, but there are no other values that are greater than that. So we have shown here that 200 is in fact an outlier. Now what I'm going to do is show the summary statistics. So if, again, I have that in my list already in my calculator, so I can do those pretty easily. So the mean is 84.75, the median is 83, the range is 150, and the IQR is 34. Now what we're going to do is we're going to remove that outlier. So we're going to take Richard Petty out of the data set, and you can just do that by going into your list and just deleting that one point. And after we do that, then we're going to recalculate our summary statistics. So I would recommend that you pause the video and try that calculation. And make sure you get the same values that I do. Without Richard Petty, we get a mean of 74.23. We get a median of 83. We get a range of 55, and we get an IQR of 30. Now, taking that high outlier out of our data did a couple of things. Number one, notice that the mean dropped by quite a bit because Richard Petty had the highest salary or the highest number of victories by far. So taking him out of the set dropped the mean by quite a bit. Also, notice that the range changed by a huge amount. So the mean and the range were really affected by that outlier when it was part of the data set. The median stayed exactly the same, and the IQR did change a little bit, but not by as much as the other summary statistics did. So the summary statistics that are most affected by an outlier are the mean and the range. Now, when we have a measure of center, like mean or median, or variability, like range or IQR, and it is not influenced much by outliers, then we say that that measure is resistant. So resistant measures means that they don't change or they are not affected by really high or low values. Resistant measures in statistics are the median and the IQR, and non-resistant measures are the mean and the range. Please do homework 5.3 in your assignment packet.